Welcome back, guys. We are going to start a new chapter today. This is going to change direction a little bit away from evolution and actually start talking about bodily systems. Uh, so we're actually going to start with one that I think it may be a little bit more challenging in terms of the depth of material, but I think it's probably the one most relevant to what I think you ought to know from a biology class in 2020. So we're going to start on chapter 37, which is Defense Against Diseases. This is going to be talking about your immune system. We'll do the first section today and the second section on Thursday. Okay, so section 1 from chapter 37 is how does the body defend itself against diseases? So it's trying to remove what doesn't belong. Okay, so the beginning of chapter 37 from your textbook introduces a short case study about this guy. It's actually pretty famous. This is Jim Henson. He created the Muppets. And in 1990, he wasn't super old when he died, but in 1990, May 4th, he felt really tired. He had a sore throat. A week or so later, week and a half later, he felt considerably worse, but doctors didn't see any signs of pneumonia or any other serious illness. So I said, okay, why don't you just go home and we'll just kind of wait this out. May 16th, he dies from massive inflammation of his lungs and multiple organ failures. So all this inflammation caused a lot of organ failure, and he died. It turns out he had a strep infection, right? The same one that gives strep throat, Streptococcus pyogenes, which is common for strep throat. The problem is this particular bacteria, for whatever reason, is kind of hard to kill. Your own immune system doesn't do a really good job of fending it off. And if you don't get antibiotics for it, it will lead to these things. That's why strep throat is always something you should go get checked out. You can't just let that go and just going wild. It's a really bad idea. So you get this inflammation of your lungs. It shuts down your organs. So strep throat is the first sign that something's wrong, but it will lead to that if you don't go take care of it. So really famous guy here. You think the doctors would have picked up on this with the sore throat, that maybe it was strep, but just kind of in light of some of the stuff that we're seeing today, similar things where people have some of these light symptoms of COVID-19, then all of a sudden it takes a turn for the worse, and they're in the hospital, and at that point it's often too late. So we're going to talk about how you actually try to fend this off, ways that we as a population have come up with healthcare to try to fend this stuff off beyond just our own immune system. But try to give you some idea of how all this stuff works, which I think is important. Okay, so our immune system, while not always capable of fighting off a disease by itself, is our body's way of removing what doesn't belong. So most of the time it does its job without any extra help, right? Without any outside help. It's pretty efficient at that, but there are certain things that it just can't fight off. Pathogens that we have yet to get just a natural immunity to. So things to keep in mind when we're talking about the immune system, like what does it actually need to do its job correctly? The first and one of the most important things is it needs to be able to differentiate self cells from invader cells. How does it know that it belongs to you or belongs to something else? If it doesn't know how to do that, it starts killing the good stuff too, which we don't want. So this is an important step, is it's got to make sure it differentiates self from invader cells. How does the immune system kill invader cells and not self cells? So once it realizes the difference between the two, making sure that it only kills the bad ones. And then lastly here, how can some microbes and viruses evade the immune system and cause deadly diseases? So how can we, how do these things get past these couple of checks here and still not get fought off, which we will eventually arrive at. So just kind of some basic information about the stuff that you come in contact with every day. Every day you come into contact with millions and probably billions of microbes. Bacteria, fungi, viruses, though when we actually start talking about viruses, you'll learn that viruses really aren't living. They're really not living. The other two are bacteria and fungi. And COVID-19, the stuff that we're dealing with now, is a virus. Okay, so it's not this bacteria or fungi. It's actually a virus. And bacteria, well, we do have antibiotics. They're getting a little bit harder to treat. Fungi and viruses are a lot harder in terms of healthcare to try to manage, and we'll try to get into that before the end of this chapter. But that's one thing to note about the one that we're dealing with right now is it's actually a virus. So things like antibiotics don't work because antibiotics treat bacterial infections. We need antiviral drugs, and those turns out are really hard to make. Antibiotics, we got lots of those. We don't have a lot of antivirals, and they're very expensive, and they have to be very specific to a virus. So that's why it's not like we can just go to the pharmacy, pick out an antiviral drug, and start giving it to these people. We'll get back into that. I just kind of want to give you a little heads up on where things are going. Many of the microbes are harmless. These millions or billions that you come in contact with, they do not interact with human cells. For whatever reason, they're not going to find you as a useful host. They don't thrive in your conditions. Perhaps your internal body temperature is too hot. Whatever it might be, most of the stuff you come in contact with either stays outside of you or doesn't have a good host inside of you. So most of the stuff is harmless, but some are what we call pathogens. Okay, and so these particular microbes, they're going to infect a host, use the host's cells to reproduce, and spread that stuff to new hosts. Okay, so if we're talking about pathogens, they're actually harmful. They're not all going to kill you, but they are not good for you. Some of these are fatal. We'll talk about a few of them. Cholera is often fatal. Basically, it gives you such extreme diarrhea that any water that you manage to get down basically just immediately comes back out, and the host usually dies of dehydration. So that's just an example of one here. This is to the best of my knowledge, at least right now, a picture of what a COVID-19 viral capsid looks like. And we'll talk more about viruses before the end of this unit, but just kind of showing you what this stuff is, what you come in contact with. You really are coming in contact with millions and billions of these things every day, most of which doesn't ever affect you on a macro level. It's all micro level stuff that gets taken care of quickly. So how does the body defend against disease? Many of these diseases have been around for centuries. Cholera has been around for a long time, and we just mentioned that one. Measles, tetanus, chickenpox, bubonic plague, which I know that's you're talking about the Black Plague from like the 1300s in Europe, but it still exists. You can still get the plague. It's not as common, obviously. Our sanitation has picked up quite a bit in the last 650 years or so, but it's still out there. A lot of these things we do have vaccinations for. There's your MMR vaccine is measles, mumps, and rubella. You get that when you're an infant. And that protects you against measles. You get a tetanus shot, I think it's every 10 years, to help protect you against tetanus. There's, in the last 15, 20 years, there's been a chickenpox vaccine. I don't know if there's one for bubonic plague, but it's pretty uncommon anymore, so I don't know if there actually is one. You guys might have to look that up. But a lot of this stuff is very recently appearing. HIV has really been a problem in only the last 35, maybe 40 years. Ebola, that one's pretty darn recent, in the last 5 to 10 years. Avian flu, I don't know why there's an E on that there. And then, of course, the one that we're dealing with right now, this COVID-19. And if you'll notice, we get a lot more of viral infections in terms of actually becoming a pandemic level sort of things. It's because viruses can mutate very, very quickly. Bacteria do mutate as well, and that it is still a very big problem. We'll talk about some issues of bacteria that's resistant to antibiotics, but viruses are a real problem. They can mutate pretty darn quickly, and as I told you a few minutes ago, they're a little bit harder to treat than the other two, generally speaking. But bacteria can be problematic. Staphylococcus aureus, this is if you hear about people getting a staph infection, this is one of those. These are real nasty things too. This will end up in the hospital with a staph infection. Staphylococcus is the name of that one. So with the large variety and presence of all these pathogens, why don't we get sick more often? Right? If you're coming in contact with millions and billions of these things, odds are some of them are going to get inside of you. So what's actually going on. Well, humans have evolved to fend off these threats, and the pathogens have evolved to infect their hosts. So these pathogens keep evolving to find a host that they can reproduce and get transmitted to a new host, and human immune systems keep evolving to try to fend these things off. You create things called antibodies. We give vaccines to create antibodies, and we try to fend these things off. Our bodies learn to identify what belongs and what doesn't belong, and it does its best to kill the foreign pathogens. So it's trying to recognize what doesn't belong inside of you. So we've got three major lines of defense. We're going to talk about vertebrates. There are other ones out there, but we're just going to stick to vertebrates for the sake of keeping it simple and related to humans. We're going to have non-specific external barriers, non-specific internal defenses, and then we'll talk about the third one here on the next slide. But the first one, these non-specific external barriers. And we're talking about the term non-specific here. Okay, what that's referring to is the fact that it doesn't specify a pathogen. Okay, it's just a general block. All right, it's something that's going to try to take out every single pathogen that comes its way. It's not going to target a specific one. Okay, so non-specific. It's not looking for anything in particular, but just barriers. So what are these? So external barriers are outside of you. They prevent most disease-causing microbes from entering the body altogether. So most of them never get a chance to go inside of you. They're primarily anatomical structures, so skin and cilia. So your skin has a really good job of keeping stuff outside of you. And secretions, so things like tears, saliva, and mucus. So these cover the external surfaces of the body and line cavities open to the outside world. So the holes in your body generally have some kind of secretion or something to protect stuff from getting inside of it. And so, like, you've got, mucus in your nose, you've got wax in your ears. That's all designed to keep things out. Okay, so non-specific, again, doesn't specify for one particular pathogen. So what about inside of that? So let's say it somehow makes it through that outside defense. We have internal defenses, and these are just non-specific internal defenses. They're not targeting a specific type of pathogens, just all things that don't belong. If the exterior barriers are breached, the innate immune response rises to action. So some white blood cells engulf pathogens or infected human cells. Chemicals released by damaged body cells and proteins released by white blood cells trigger inflammation and fever. So you have an example over here of a white blood cell. I believe that's a phagocyte trying to track down this bacteria here. So this is your type of white blood cell. It's trying to track down this bacteria to engulf it, break it down, and get rid of it. But it's going to go after anything. It's not like particular for that particular bacteria. Okay. You can also have cells that are infected releasing chemicals that say, "Hey, I'm in trouble. Something come over here and help me." And the proteins released by the red blood cells trigger inflammation. So things that get red, swollen, pain, and fever. And we'll talk about why that fever is important also pretty soon. In our third line of defense, now we're getting specific. Okay, so now we're talking about something that's targeting a specific bacteria or a specific virus or a specific fungi. So this particular thing has made it inside of your body through the external defenses, just the innate immune system internal response, and now what do we have left? The third line here is very specific. And so this is called the adaptive immune response. So immune cells selectively destroy the specific invading toxin or microbe and then remember the invader, allowing a faster response if it appears in the future. So this is how we build up things called antibodies, which we'll get into later on in this chapter. An antibody is a very specific thing that helps recognize stuff you've had before. So that's what vaccines are trying to do, is they're trying to get you to build up antibodies to things so that if you see it or you come in contact with it, your body automatically knows to just kill it. And so that's why vaccines are important. Okay, so this is just the last slide here for today. Over here on the left side is the difference between innate immune response and adaptive immune response. We kind of already mentioned those sorts of things. Over here on the right, We're going to come back to these in the next few sections. Section 2 is going to cover up to, I think, where mast cells in. So it's going to talk about these first ones here and what they do in particular. So that's what's coming up on the horizon here in 37.2. Well, that's it for today.